right, this is Math 208, Week 5, Section 5.1, using the product rule. So it says to simplify the expression, and basically what they're saying is make that whole little 8 times 8 cubed, make it simpler, like find the actual value. Now, I'm not entirely sure. Well, let's get to the part that I am sure about. So what does this mean? So 8 means 8. Okay, that's pretty obvious. But 8 to the third power, what does that mean? That means 8 times 8 times 8. And so, all told, this really means 8 to the fourth power. So 8 times 8 to the third power equals 8 to the fourth power. Now the part that I'm not sure about is if they want us to leave the answer as 8 to the fourth power, or do they want us to change that 8 to the fourth power to some actual value. So like, for example, 8 to the fourth power is equal to 4,096. So I'm not sure if my math lab wants us to leave the answer as 8 to the fourth, or if they want us to leave the answer as 4,096. So here we go. On this one, we've got 6 to the third power times 6 to the fourth power, and that means 6 times 6 times 6, because that's this, times, and then 6 times 6 times 6 times 6, because that's this. And then what do you have all together? Well, you count 1, 2, 3, 4, 5, 6, 7. So this is equal to 6 raised to the 7th power. Now, if you want, you could type in 6 raised to the, type it into the calculator, and you could say 6 raised to the 7th power, or you could just do 6 times 6 times 6 times 6 times 6 times 6 times 6 into the calculator, and you would get this crazy answer. You're going to get 279,936, all right? Now, I think my math lab will accept this answer, which is far simpler than this answer, but I believe my math lab will accept either answer. You might as well type in the easier, shorter answer. All right, this is the exact same thing, only now we're going to variables, but it's the exact same thing. So you start off with, what do we have? Well, we have x squared times x to the 8th. All right, what does this x squared mean? It means x times x. What does this x to the 8th mean? It means times x times x times x times x times x times x times x. Let me make sure I have enough. 1, 2, 3, 4, 5, 6, 7. Ooh, I don't. Times 8. Okay, so I have 8 x's being multiplied over here. I have 2 x's being multiplied here because the exponents say so. So what do I have all together? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have x raised to the 10th power, and that is your answer. All right, more of the same. So we're going to start off by writing our problem. Z to the 5th times z to the 6th times z to the 4th. And this time I'm going to go down because I need the room. So this is going to be z, 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 z. So that part is z times z times z times z. And then we have times, that's this times right here. And then what do we have? Well, then we have z to the 6th power. So that's going to be z, 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 z. And those are all being multiplied. And then we have this times comes here. And then what do we have? We have z to the 4th. So z, 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 z. That's tons of writing, but that's how you do it, right? Now, what do we have? Well, we have all of these z's being multiplied together. So what is that all together? That's 15 z's. So our answer is z raised to the 15th power. All right, so we're going to simplify this expression, and we're going to begin by writing the expression out. So that's going to be 9d squared times 2d to the 5th power. Now, remember, this 9 in front of the d means 9 times d squared. All right, so this means 9 times, and then that d squared means d times d. So this d squared is d times d, and then we have this times sign comes down, and then what do we have over here? This is 2 times d times d times d times d times d. So let's make sure I did it right. So I've got the 9, d squared means I'm going to have 2 d's being multiplied, and I've got the 2. Now, it kind of looks like a z from the previous problem, and then this d to the 5th means I should have 5 d's being multiplied. And then what I can start using the commutative property, and I can move things around, and I can have 9 times 2 times, and then I've got d times d times d times d times d times d. How many is that supposed to be? It's supposed to be 1, 2, 3, 4, 5, 6, 7, and I have 1, 2, 3, 4, 5, 6, 7. All right, so simplifying that one last little step, 9 times 2 is 18 times, and then all of these d's is d raised to the 7th power. So the answer is 18 times d to the 7th power. But you don't need that little time sign. So that little time sign here we can erase. So really the answer is 18 d to the 7th power. So as it gets more complicated, I find that students have an easy time with the rules themselves. It's they're having a hard time understanding the language of mathematics and how these variables are written and what that means. Like, they understand the rules. That's easy. They just don't understand what's been written in the first place. So I'm going to start by writing down the problem. So it's 8 times the quantity negative x y squared times the quantity x to the 4th y. All right, now this negative is attached to this x only, and this exponent 2 is attached to the y only. All right, so if I'm going to write this in expanded notation, I'm going to get 8 times negative x times y times y. All right, so all of this is right here. And then these parentheses next to each other means I'm going to multiply. So there's like a multiply symbol there. And then I've got x times x times x times x times y. And where did that come from? That came from right here. So now that I've written it in expanded notation, if you really want to think about it, this guy right here, that little negative x can be thought of as negative 1x. And so we really could multiply the 8 times the negative 1. That gives us negative 8. And then what do we have? We have an x, 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 x. So we've got 5 x's being multiplied. So that means times x to the 5th power times, and then we have 1, 2, 3 y's being multiplied by each other. So that's times y to the 3rd, and that is our answer. But again, we don't really need those multiplication symbols down here. We could just put them all together and say that the answer is negative 8 x to the 5th y to the 3rd, and that is your answer. So this is a little tricky just because of the vocabulary and the words that they're using. They're saying simplify the expression, but express your answer as 1 base to a power. All right, and so we're going to start off by understanding that this is x plus 2 times the quantity x plus 2 raised to the third power. So this third power is only raising this guy to the third power. So I'm going to start by saying, okay, equals, and that's x plus 2, and that's this piece right here. And then we've got times, and why is it a times? It's because those two parentheses are next to each other, so that means we're going to multiply. And then we've got this guy, and I want you to think of this as x plus 2 times x plus 2 times x plus 2. Because the exponent was a third to the third power, that, whoa, geez, I lost it. So let's go. There we go. So because the exponent was to the third power, we have x plus 2 written down 3 times, plus we have an x plus 2 written down here a 4th time. So this really means, in parentheses, x plus 2, close the parentheses, raised to the 4th power. And that is the answer they want. So one base, the base is considered this x plus 2, and to a power, the 4 is considered the power, the exponent. So the answer is x plus 2 raised to the 4th power. You have to have these parentheses. If you put x plus 2 raised to the 4th power like this because you forget the parentheses, that means only the 2 is being raised to the 4th power instead of the whole thing being written out 4 times. This is another example of the exact same kind of thing, only this time it's getting a little bigger. You've got x plus 1 quantity to the 5th power times x plus 1 quantity to the 2nd power. And so what does this mean? Well, this first part means we're going to write down x plus 1 5 times. X plus 1 times x plus 1 times x plus 1 times x plus 1 times x plus 1. So there's our 5 of them because it was raised to the 5th power. And then don't forget, this means multiply, but when you're dealing with all parentheses, you don't actually have to write the time sign. And now we have this x plus 1 raised to the 2nd power. So I'll do that in blue. So now we have an x plus 1 times another x plus 1. And so this is this guy written in expanded form. I wrote the exponents in expanded form. Now we're going to condense it again. We're going to mush them together because what do we have? Well, we have x plus 1 quantity, so I have to remember to put the parentheses, raised to the 7th power, because that's how many of them are being multiplied by each other. And then here, simplify the expression. So here, it's a distributive property. So I'm going to put, and the reason why we suddenly have the distributive property, because inside our parentheses is a minus sign, and outside we have just a plain old number. So it's x times x squared minus 11y squared. And so you've got a number times a quantity. And so that means you're going to do x times x squared, and then you're going to do x times negative 11y. So that first x times x squared, in your head, you should be able to see this is going to be x times x times x. So that's really x cubed. And then here you have minus, and then it's going to be x times this 11y squared, or we could say it's going to be negative 11xy squared. Now, how the heck did I get that? Because I kind of jumped around. I'm going to go over here on scratch paper, and I'm only going to be thinking about this red portion of the distributive property. So it says x times 11y squared. So that's going to be x times 11y squared. So really that means x times 11 times y. And you can use the commutative property to move it around and make it look pretty, but basically you're going to get 11xy to the squared, y to the power of 2. We traditionally put the letters in alphabetical order, but technically, if you wanted to, you could have had 11y squared x, and that would also be correct. Either of these would have been correct. Bringing it over here, not forgetting the fact that there was supposed to be a negative there in the first place. So the answer is x cubed minus 11xy squared. And really, that y is only, that squared is only connected to the the y. Gee whiz. That squared is only connected to the y. It's not really connected to the x or the 11 at all. All right, last problem just gets a little bit bigger, but it's the exact same kind of concept. So you've got 3x cubed times the quantity 2x squared plus 5y. So this is another perfect example of the distributive property. So you're going to do 3x cubed times 2x squared. Then you're going to do 3x cubed times positive 5y. So that means we're going to do this 3 times x cubed times 2 times x squared, all right? So if you need to, you could go over here on scratch paper, you can go over here, and on scratch paper, you can write 3x cubed times 2x squared, because that's what this portion of the multiplication is. So zooming in a little bit, save us a little bit of room. This is 3 times x times x times x times 2 times x times x. So the 3 and the 2 can be multiplied, so that gives us 6. And then all of the x's gives us x raised to the 5th power. So that becomes 6x raised to the 5th power. So 6x raised to the 5th power. And then it's going to be plus because we've got positives here. And now we've got this 3x cubed being multiplied by 5y. So that gives us 15x cubed y. And if you need help on that one, I saved a little bit of work. I didn't actually show my thought process in my thought bubble over here. I'm kind of jumping a little bit. So if you need help, give me a call.